Hi, everybody. My name is Addison Snell. I'm with Intersect 360 Research. Thank you, Scott, and thank you to SNIA for having me here today. I think this is a fantastic organization. We did a lot of work with SNIA in partnership back when active archives were really the big news. And ever since, we've seen a lot of the rebranding and expansion of focus of SNIA over the last couple of years. It's really been our intention to do a lot more partnership together. I think this really has SNIA has their fingers right on the pulse of where things are going in high-performance data center markets right now. I presented in Denver at the last SDC back in April. I'm going to give an updated version of that same talk based on something that we wrote and published back at the end of January this year, entitled 5 Big Questions for HPC-AI in 2025. I should have put a QR code to that article on there, and I'm sorry I didn't, but if you do a search on that and my name and HPC Wire, you should be able to find it pretty easily. And in any case, I'm going to walk through the 5 big questions, and the repeat of that is very intentional because I think these were the right questions to be asking, and we keep going back and touching them throughout the year, and I've updated the talk with some fresh research as we continue to look at these questions throughout the year. For those of you not familiar with us, Intersect 360 Research, we're industry analysts who focus on high-performance data center markets, which for most of our nearly 20-year history now, you could have conveniently called high-performance computing, and that would have been sufficient. It includes things like cloud, it includes things like big data, which is washed through, but the thing that's really transformed the discussion is AI because of its influence of what's come in from the hyperscale side. And hyperscale is something that's been part of our methodology since our founding, and that's where most of the early AI and machine learning spending came from, but it now dominates not only high-performance computing, but the entire data center landscape, and we continue to look at that influence through our research as we've been researching the effects of machine learning for the last 10 years. We have a growing team. We brought on some new analysts this year, Kevin Jackson, who was previously writing for HPC Wire and Science Node before that, Antonia Marr, I hope many of you will get to meet as well. She's based in Germany. We've been talking for a long time about talent development is the #1 problem across our industry. It comes up in all of our end user interviews, comes up in all of our discussions with vendors. Where do we get new generations of talent? I looked around the landscape of HPC and AI analysts, and of those who had any kind of recognition at all, I was the only one who wasn't 60 yet. So if I wait until I am 60 to solve that problem, I'm going to be too late. And Kevin and Antonia are fantastic. You're going to be seeing a lot of their work. That's the future of this industry coming along. Christine Franzak and Paul Musio are helping with the coordination of this user group that Scott mentioned, the HPC-AI Leadership Organization. Here I do have a QR code. This is a global user group for all organizations that are practitioners of HPC and AI. There's absolutely no cost to join. You get access to content. You get private Halo events, whether virtual or in person. This is the group that's steering the course of our research going forward by suggesting research topics and participating in surveys. The good news is you get that back to you as part of the organization. If you're an end user organization who touches HPC or AI, please hit that QR code and join. We would love to hear your voice. If you're a vendor, you can also follow that link and apply to join. What will happen is you'll get rejected. And it's not because we don't like the vendors, but we do. But the question people ask us is, what do end users tell you about this? And so we really try to keep the vendor voices out of the surveys because we want to represent the buyer voices, and that's what this is, and that's the foundation of our research. So getting to 5 big questions, the #1 question on everybody's mind was how big can the AI market get? Now, anytime we go count things as analysts, I have this annoying habit of putting the question back on the person asking, which is, what things do you want me to count? right? Because when we talk about something as vague as the AI market, I mean, at some level, this smartphone is part of the AI market. Your thermostat now is part of the AI market. Your car is part of the AI market. Do you want me to count all of those things? Well, if you're asking me, probably not. I'm going to be focusing on the data center components. I'm not even going to count things like edge PCs or AI PCs, things like that. Our company is looking at the data center segmentation, okay? It's not that the other stuff doesn't have AI in it. It does, but I'm going to count data center components at Intersect 360 Research. Then, if I ask some of the prominent suppliers, what's the difference between AI market and data center market? They'll tell us, nothing. It's all the AI market. Okay, well then that's also not useful to just have it be a synonym of the data center market. We're trying to, in our segmentation now, get down to two big things. One is, what is accelerated computing in some sense, which doesn't strictly have to be a GPU. It could be some other type of accelerator. It could be a high-performance network. It could be lots and lots of memory. It's everything that used to be an HPC we'll call part of that accelerated or high-performance market, but certainly everything with GPUs and accelerators also counts. And we're also segmenting what's some sense of hyperscale versus what's some sense of outside of hyperscale or on-premises. On-premises is not exactly the right word because it would include things like colos, but you get it. Non-hyperscale is what we're counting with on-premises. And the market looks like this right now in 2024. This hyperscale component, does this have a laser pointer on it? That would be cool. This hyperscale component has been zooming. This already has been doubling, tripling every year to get to this point. And now we've seen this expansion here again. So these golds and browns and yellows down at the bottom, these are the accelerated portions. You can see how much it's grown year over year from 2023 to 2024. And these are the non-accelerated or just general enterprise computing that's not HPC or AI portions of the market. We don't really specialize in these areas, but we do count them so that we can show how much the accelerated portion takes up as part of the overall. And you can see it's a growing proportion. And then even among the accelerated parts, it's still mostly hyperscale, right? You get a lot of things that aren't AI that still go into hyperscale now. Your email, your music, your video games are still getting served, your movies are getting served out of hyperscale now. And hyperscale grew mostly out of those data center segments, creating data center markets out of things that didn't used to be data center markets. You didn't used to have maps in data centers. It used to be a paper map that you would, now it's a data center market, right? So things like that really took off with cloud, and as it continues to grow, we do think it will flatten out eventually. You get to like an all the money in the world problem is what Chris Willard, my partner and original chief research officer, called it. You have to look practically at a global scale of how much of the worldwide economy something can take up, and does it make sense? And we model this individually for all of these segments. But what's interesting is over the next couple of years, where the growth is, we think is going to shift. It's been in hyperscale, and we think hyperscale continues another big growth year again. But where the bigger growth rate is right now is in what we call in these segmentations AI-focused clouds. That's kind of a precise thing to call them. The kids call them neo clouds these days. These are your CoreWeaves, Lambda, Denver, Nebius, whatever. They're AI-focused clouds in the sense that cloud computing is their main line of business, and they serve out accelerated instances. As opposed to a multi-line hyperscale institution. If you're at Amazon or Microsoft or Google, yeah, you're a primary, or Oracle, you're a major cloud provider, but that's not your only or even necessarily main line of business. Google is a much larger company than GCP is, and they buy a lot of infrastructure for a lot of things outside of cloud. It doesn't have to be an American one. ByteDance, Alibaba are other great examples of multi-line hyperscale companies that buy a lot of infrastructure. So near term, it's these AI-focused clouds of the highest growth rate, but then what really takes off over the remaining part of the forecast period is what we're calling national sovereign AI data centers. These are going to be AI data centers that are owned or controlled in some way by a national government behind them. There are some examples of this already in the market, most notably in Japan with ABCI and with G42 in United Arab Emirates. Some of the near-term ones are coming online this year in Saudi Arabia. There's been a lot of Middle East-focused spending. The reason for such a high growth rate is we think there's no way that the United States and China stay out of that. And by one way or another, you get into government-owned or controlled data centers, even in the United States. They might need some kind of funny mechanism for getting to that, but I think they will. When it comes to looking at things outside of hyperscale, we've done a lot of budget research on what you could call enterprise AI, how they're spending their money. We reached out to over 400 enterprises in US and Europe. These are commercial only. These were medium and large size. So the only criteria was it's a commercial organization with at least $10 million in annual revenue, which isn't even especially big. These are medium to large size enterprises. And we found at that level, 92% of enterprises had budget for HPC or AI or both, right? So we would define HPC modeling and simulation. Do you spend money on that? We define AI and machine learning. Do you spend money on that? And if no to both, then they would drop out from there. And we continued with the other 92%. And here's what we found, that when we break down those 92%, that left us with 393, so now below 400, 393 organizations. 86% of them had both HPC budgets and AI budgets as part of their overall IT spending. 10% had AI only and no HPC. 4%, and this is really going away, this is what fell off from the previous year, 4% had HPC only and no AI. It's getting to where we can conveniently ignore the idea that someone has HPC spending but not AI spending. That would be very rare. That's going away in the market. But the big learning that we have trouble getting across is that where you find one, you usually find both. Now, then once we do that, we can break down, okay, HPC and AI, are the budgets together or are they separate? They're usually together. Once they're together, are they mostly HPC or are they mostly AI? They lean AI. But for a lot of companies, there's not even a distinction. They don't say there's a difference between HPC and AI, so why are you even asking me, right? It's the same thing. This is starting to permeate how people use these terms. We've spent decades trying to describe commercial use cases of HPC in areas like automotive, energy, aerospace, pharma, finance. There's all kinds of examples, and they've been there for a long time. And it's like every year, it's this perennial discussion about, do businesses really use HPC? Yes, they really use HPC. And we finally got comfortable with that. Get ready for that to go the other way. Almost everybody in the vendor community anymore, when they say HPC, they mean strictly academic government research labs. And if it's on the commercial side, it's AI. And it really doesn't matter what they're doing with it. It's AI. I saw a great slide at the AI Infrastructure Summit last week describing AI use cases, and it described them vaguely with images. One of them was an image of a crash simulation, strictly finite element analysis. I'm like, you could have an AI wrapper around that, I guess, but you're depicting an HPC simulation. Same with molecular modeling and chemical engineering. It's hard to think of what kind of advanced computing you couldn't rebrand as AI at some level. Is this cutting in and out? I can't tell. Okay, I'm going to assume it's fine. Come up and get me if it's not. Now, when we look at that, so let me go back to this chart for just a second. Getting outside of hyperscale, there is this yellow component here that's the HPC AI market, and then there's a little sliver that's the pure AI that has no HPC in it. There is still some of that. And what we have here is a stable, even growing market, but it's a stable component of something else that's larger and growing faster. So it's getting less and less attention over time. This forecast for that segment should be good news that it's continuing to grow, and that kind of growth in a normal year would capture a lot of attention. Hey, let's go get that. That's not where people's attention is now. Their attention is in the larger hyperscale, neo cloud, national sovereign AI. That's the market that's really growing a lot. The reason for the dip here in 2025 in spending is entirely from the reduction in grants in the United States in academia. Academic funding got slashed this year by the current U.S. administration, which is another question that's coming up later in here, and it's a dramatic enough effect that it's visible on the global scale, that if you take out one geography and one segment, you get a dip there. We think it will recover, but that takes some time. The reason that matters is because the storage and networking discussion is different when you talk about the non-hyperscale or on-premises HPC AI market versus hyperscale AI, including what percent of the budget is going to storage. And on-premises, we find tiered hybrid storage that includes flash and disk and tape versus the all-flash that we get in hyperscale AI. Parallel file systems are still a major discussion. HPC storage specialists, I mean, and what the networking is, InfiniBand, Ethernet. I think UEC, Ultra Ethernet Consortium, is one of the most important initiatives going on right now. It's a really important discussion in the hyperscale side. I heard it discussed last week at the AI Infra Summit in terms of how we're going to be delivering scalable networking to hyperscale AI, and that will then influence what's available on the HPC AI side. So there are differences for storage networking, also for the other areas, compute or whatever else you like. So describing this enterprise AI opportunity, it's in some ways a little bit of a misnomer, because when we're segmenting this out, you have to realize that in the AI market, most of it is the hyperscale market, and most of that has nothing to do with enterprise AI. The big part of the market is pictures of squirrels riding bicycles on their way to a seminar, right? It is Gen AI stuff, but it's not enterprise at all. It's consumer. Then when you get into enterprise AI, most of that is horizontal. It's things like customer service chatbots. It's things that are bottom line savings, or coding, right? I'm going to get rid of or optimize my coding team and do a lot of that with AI. Very little of it so far is what we would call top line, having to do with innovation, R&D, help me with my design a car or find oil or things like that. It's there, but from a market size perspective, it's just not where the money is right now. And there's a limit to how far you can go with the cost saving thing, right? How much money would you spend to save $100 a year, even if you annualize it? Is it infinity because it's $100 every year? I doubt it. It's hard to find people who will spend $500 to save $100 a year because the ROI is too far out, right? Your break even on that is usually about $200 to save $100 a year at most companies. Other than that, it's just not what they're going to invest in. And I'm not sure that revenues really go up as a result of AI. They'll shift. Different things will go different places, but are you really going to fly more because your airline has a customer service chatbot that's AI powered? Do you take more flights as a result? Mostly no. Mostly the revenue line doesn't go up, right? So if all you're doing is saving costs, for the time being, there's a limit. Someone in a keynote last week said that they expected this AI for science to be the third wave of AI innovation, which is 5 to 10 years out. So I believe it's there, but it'll take a little bit. Question number, so that was all about the size of the AI market, which leads to question 2, is hyperscale going to completely take over enterprise computing? Cloud has been penetrating within HPC and AI, but it's been hitting a limit, right, in terms of how much of the overall HPC budget people are willing to give to cloud. And in fact, a lot of our surveys have shown a preference among end users for on-premises computing. And that has always been there throughout the whole cloud revolution, mostly because of cost. I will tell you, I have a history with this. Cloud has been the most contentious, the most focused thing throughout our history until now AI took over, right? But other than that, cloud has been the number one thing that people have asked us about. In 2011, we lost a major client because we did not forecast that the entire HPC market would be lost to cloud by the end of the forecast period of 2016. In the year 2013, I was literally booed at a conference for suggesting that anyone would ever repatriate data back out of the cloud. I got literally booed. My cloud-based client, I got chewed up by a hyperscale company for an hour over this chart for suggesting that there was an asymptote to cloud penetration. I get it. Everything is better in the cloud. Cost has been the primary reason that there's been a balance. The new ones that have come up, especially with AI out there, are data sovereignty and data locality, that there's been a preference for on-premises. What I'm here to tell you now is that by the end of the new forecast period, we could see an elbow and it'll start to go the other way. And that's strictly because of the supply side dominance of hyperscale computing. As hyperscale reaches nearly 3/4 of data center spending worldwide, and these data centers are getting built out gigawatts at a time. What the HPC community still hasn't fully awakened to is the idea that our top 500 list is not particularly impressive anymore to the supplier community. I visited El Capitan on Friday. I went and got to see it at Livermore. Fantastic. I missed the ribbon cutting back in January. I was out of town. I'm going to go see Jupiter in 2 weeks in Jülich. I love these systems. They are magnificent achievements that we ought to give a standing ovation to. They are beautiful, beautiful systems. But when we say El Capitan is the most powerful supercomputer in the world, you got to understand that that is a lie and it's not even close. It is off by 2 orders of magnitude compared to what the hyperscale companies are building on the regular. I mean, you know, a company like Microsoft or Amazon installs something like El Capitan by the end of the week, and they don't even blink. That's a 40 megawatt supercomputer? We're talking about gigawatt data centers that get built out, and they're talking now about how do we link multiple data centers together. It's Microsoft's AI infrastructure barely fits on Manhattan Island, right? If you put it all in one place versus a supercomputer that would take up one city block. It really is not close. And we wrote back more than 5 years ago that none of this will slow down in the next few years. And unless there's a change to the competitive sphere, tier 1 hyperscale companies are going to become even more powerful within the forecastable time frame. Such market power is not unprecedented in the world economic history, but it's not been previously seen at this level in the information technology era. When you get major world governments trying to curry favor with individual companies, the macroeconomics is upside down from its normal state, right? But the current geopolitical environment supports it. I don't think it lasts for like 20 years this way. Things change it, whatever it is. But in the near term, you're asking me to do 5-year, 10-year forecasts. It keeps going like this because that's the world we're in right now. And if that starts taking up suppliers' attention, then cloud first becomes your main option for getting access to new technologies because that's where they're all going to be going. So I pointed a little bit to government regulation. The focus this year has been on the US administration, not because I'm an American. We try to have a global focus, but this administration in particular has been, and I try to, look, I'm not trying to tell anybody who to vote for here, and I try to stay really politically neutral on this, and as an analyst, measure what do we think the effect on the market is, right? And what everyone I talk to agrees on is that this is an unconventional government. It is an anti-government government that is going after institutions Whether you think that's a good thing or a bad thing is a matter of political preference or taste, but they are going after them, and there's a new way of doing things. I attended High Peak this year, and they in Europe, they said the same. I was there on inauguration week. We had fun conversations. And our global Halo group have all flagged nationalism issues as threats to progress. The Stargate project was announced within days of Trump getting sworn into office. This is, hundreds of billions of dollars of AI investment, but it's not even strictly American investment. Two of the major investors there are non-American, SoftBank and now I'm blanking on the Emirati company. I think it's DGX. It's a 3-letter acronym, but it's a shell company that was founded by the UAE government just last year, is one of the major sources of money behind this. That's a mechanism where you could see government control of AI data centers, even if they're not strictly owned by the government. Do people recognize this logo here, the dollar bill that's gold? Anyone know what that's the logo of? It's not Bitcoin. That has a B in it. That's the Department of Government Efficiency, DOGE. And they, went after all of these other organizations, right? It was strange to go into a forecasting cycle where we were asking, well, if you're at NOAA or NASA, what if the government wanted to tear down that organization and say, well, you could just do that in the cloud? Or change their mission statement, right? The mission statement for NOAA has changed. It's not about oceanography and climate anymore. It's about mining the seabed floor for rare earths. That's what NOAA is supposed to do now. So again, you can think that's a good thing or a bad thing, but you have to understand the mission has changed, and this is having a significant effect on the HPC and AI market worldwide. Everyone ought to download this and read it. You can get it for free. This is America's AI Action Plan. And in the introduction, I don't want to turn around and read there. I'm going to read it off my screen. The introduction, these paragraphs are in there barely separated from each other. Winning the AI race will usher in a new golden age of human flourishing, economic competitiveness, and national security for the American people. AI will enable Americans to discover new materials, synthesize new chemicals, manufacture new drugs, and develop new methods to harness energy, an industrial revolution. All right, I'm going to pause there for a second because this is part of the switcheroo that we get with AI. You describe those applications, and it goes on like that throughout the document, and it's curing cancer and predicting the weather and all these things that AI are going to do. And I believe that that's true. AI and HPC are going to be merged in a long-term way where AI is doing those things. It's slow. It doesn't happen all at once. That market right now is still predominantly an HPC market. But you buy into that vision, which is the sizzle that they're selling instead of the steak, and say, great, I love it, go do it. The money gets taken, and then you get, well, here's your customer service chatbot that everybody wanted. Okay, that chatbot isn't what's going to go do those other things that you just said. That AI is different. And if we're going to talk about this, we have to segment out what's the top line R&D AI, what's the bottom line horizontal enterprise AI, and what's the consumer AI, right? That's the squirrels riding bicycles. They're three different things, and something that's good at one isn't necessarily good at the other. I'll say another thing here, which is, here's the thing about AI in science. AI is not designed to give you the right answer. That's what math does. AI is not designed to give you the right answer. AI is designed to give you the expected answer, and that's different. We call it AI training, like training a dog, right? And it's actually not a bad metaphor. Is a dog attacking a person the wrong answer? In most cases, yeah. There are some where it's the right answer. Can you train a dog to do it? Yep, you can. And you can train AI to do all kinds of things. The right answer is the one you train it to give you, right? So You know, I was at ISC and said something similar to this this summer. And someone said, well, if someone built an AI model that said the climate wasn't warming, no one would believe it. I'm like, bullshit. Someone could train AI to say that, and many, many people would believe it, and many of those people would be powerful, right? You can train AI to give you whatever answer you want. Okay, then, later in the introduction it says we need to build and maintain vast AI infrastructure and the energy to power it. To do that, we will continue to reject radical climate dogma and bureaucratic red tape, as the administration has done since inauguration date. Simply put, we will build, baby, build. This administration is weird in a way because, and I'm not, again, you can say it's good or say it's bad, but this administration is pro-technology and pro-business, but also anti-science. It is pro-technology and anti-science, right? It doesn't want the science answer, it wants the technology answer, and those two things aren't the same. So and we're going to see a lot of AI building, but it's going to be focused in a particular area. Question 4 is, can anyone challenge NVIDIA? I'm going to go a little faster on these. We've been tracking all kinds of things around the growth of accelerators and NVIDIA's dominance, and that continues. And that race is pretty much dead, right? These are older charts if you go back and look at them. The most interesting thing that I will pause and point out isn't the growth of accelerators, it's this histogram, which has held up that when you get into these blended on-premises HPC and AI markets where it's mostly shared infrastructure, the most common configuration we see still is 4 GPUs per node, which is different from like the 8 and more GPUs we see in per node that we see in the pure AI areas. They indicate these mixed environments. And the funny thing about the 4 GPUs per node is in many cases when we really do the in-depth interviews with customers, you find that that's the compromise that both sides hate equally, right? That when you're doing pure AI, you really wanted 8, and when you're doing HPC, you really wanted 1 or 2. And maybe composability is going to ride to the rescue here, but we also see some sites like at Barcelona, they're doing the other thing. They're like, here are our 8 GPU nodes, and here are 1 or 2 GPU nodes, right? And they're going to split it. So are these really converging, or are they going to separate? That's a thing that we're tracking. But when we look at potential challengers to NVIDIA, I mean, I've read twice in the last 2 weeks in popular press the idea that Intel somehow didn't see this AI revolution coming. I think that sells Intel short. It's not like they didn't see this happening. That's ridiculous. Intel failed to capitalize on it. I think that's true. Intel has been trying and failing to come out with a competing GPU since Project Larrabee. Right? There have been multiple generations. They just couldn't quite get it right, and that's a shame. It'd be better if there were a good, strong competitor there. AMD has one. AMD's been behind in software, and that's what holds back a lot of that dominance. There's a whole field of potential competitors, and anytime I list some, I leave out others, so apologies. Those are meant to be examples, but none of them is big enough to really challenge NVIDIA at a market level. The big thing we're looking ahead to now as we continue to track the market is what happens here, right? Because NVIDIA I've been tracking since it was a graphics company. Then it was an HPC company. Now is an AI company. The question I put to NVIDIA is, what kind of company are you going to be in the 2030s, right? Because I don't think it's stopping. This is one of the largest, most powerful companies in the world, and it's there selling to some of the other largest and most powerful companies in the world. But NVIDIA now has its sight sets bigger. It's gone into competition with its own customers on 2 fronts. NVIDIA has vertically integrated into selling complete systems, so it competes with the system providers that carry their GPUs to market. NVIDIA, in some sense, competes with HPE and Dell and Evident, right? And they've become they're close to being the number 2 system provider in HPC and AI. I think they will be this year. They also now are competing in clouds, and the cloud companies are competing with them. NVIDIA is the primary investor behind this new wave of AI-focused clouds, right, that builds up these. And in the meantime, all of these cloud companies are building their own processors to try to displace NVIDIA. That is going to be your competitive environment now for the 2030s. It doesn't happen again all at once. I see that. Thank you. It doesn't happen all at once, but that is the direction that we're heading, which leaves us with, what about good old HPC, right? The biggest discussion here for the HPC community is what happens to 64-bit computing, right? When we poll the users, it's the number one thing people still need. And that means if this was really your home market, FP64 would be the last one you would want to deprecate in the roadmap. Taking things down to 16, 8, 4, it just shows that AI inference is your home market, not HPC, and not even really the enterprise AI market where it's mostly mixed. Remember, I showed a slide, we researched it. It's mostly mixed when you get outside of hyperscale. But if hyperscale AI is your market, then sure, you reduce the precision and you go there. Programming languages are another area where it has a major effect. Python has become a dominant HPC AI language now. Now maybe your coding agents are going to make this a little easier because you can port things. But if you've got a lot of Fortran code that's legacy, you've got a problem in terms of moving that forward. Even C and C++, you have to start wondering where the future is there. So I mentioned this convergence or divergence. I think, we've got rose-colored glasses on a little bit when we talk about the convergence. From an end-user perspective side, that's what's wanted. From a supplier side, that's not where things are going, right? The suppliers are pulling apart, and that's because the primary market is the hyperscale market, not the enterprise AI or HPC market. Now, the thing is, we've heard this song before. Right? When have we talked about, oh, that's not real HPC, or those accelerate that you can't solve the hard problems that way. All those flops don't translate to real performance. We saw this in the transition from vector to scalar. We saw this in the transition from SMPs to clusters. And each time the HPC community had to go do something else. This is the direction we're going. So if you haven't been talking about Ozaki scheme yet, you're going to talk about that or something similar about how do you emulate 64-bit performance on lower precision processors, right? It's not that different from the conversation we had around parallelism. It does not happen all at once. Clusters did not replace SMPs all in a year. That was like a 10, 15-year transition. And I think we're going to see something similar in HPC. I'm actually less concerned about the math, right? And where you can emulate 64-bit math. I think you throw enough flops at it, even if they're cheap 8-bit flops, you'll get there eventually. I'm more concerned about how do you emulate a 64-bit vector instruction. I haven't heard a good answer to that one yet, but that's what the community has to figure out. All right, my last few minutes, I'm going to wrap up with some other new research. We're in the middle of these State of the HPC AI market reports. This is outside of hyperscale, polling the user community in 7 different technology modules. The first one that we published was on storage and data management. There's systems and clusters is coming out next. Interconnects and networking is in the field right now as a survey, and I'll do some highlights from the 2 of these because I'm at SNIA right now. This storage report really describes in great detail what the current trends and opportunities are for this blended enterprise HPC AI market. Where are the storage systems HPC focused? Where are they AI focused? Where are they mixed? They lean mixed. They lean mixed because that's where the data is. The data, I'm doing HPC and AI with the same data. But when we ask people HPC and AI, are the requirements the same or different? It leans different, right? So I'm using the same storage infrastructure for things that have different requirements. That comes up a lot. And it plays into this widening gap between what people say they need and what people are actually getting. This report is out now. 93% of the survey respondents said that these are important, carefully considered acquisitions, and I'm going to give away the meat of this report. Get your cameras ready right here. You're going to need to zoom in. It's a complicated chart. I made it as big as I could on the slide. We drove at this concept of satisfaction gaps. And what I mean by that is we took a list of 17 different features down here, potential features, and we asked everybody how important they are on a scale of 1 to 5. And I could have told you in advance, I/O bandwidth is number 1. It's always going to be number 1 on a scale of 1 to 5. Give me bandwidth. But we also asked people, and we've done this before, I love this analysis, how satisfied they are with available solutions on a scale of 1 to 5. That's also interesting data, but what we're looking for is the gaps. Where do you find high importance, low satisfaction? So here's I/O bandwidth is the most important one. The gold lines here are the importance scores. The blue lines are the satisfaction scores. So I/O bandwidth, most important, but it's also most satisfied, right? So it's not actually where the problem is right now. You're looking for the biggest gap. One of the most important things is performance on many small files. It's one of the most important, and it's second to least satisfied. It's nearly a full point difference between the average performance score and the average satisfaction score. This is killing people. I brought this up in one of our calls with the advisory committee with our Halo group. Academic users, commercial users, all different vertical markets. Oh man, you should have heard the manufacturers go off on this. They can't do it, the performance on small files right now. This is part of the gap. I said it's in progress right now for networking. I don't want to put up the same chart because the data is still in flight, and you'll take a picture of it and then it'll change by the end. But bandwidth, latency, yeah, they were up there. Early leader, nearly, I almost finished tabulating them. I'm like, oh, it's going to be the interoperability with CPUs, GPUs, other types of accelerators. That was the second biggest satisfaction gap. Biggest satisfaction gap in networking in early voting, OEM support and service. They need vendors who can understand the networking and service it, and they're not getting it right now in the market. Now that could change by the end of the survey, but those are the top 2 right now. I'm mentioning this widening gap this widening satisfaction gap and talking about people are chasing a different opportunity. This is my concluding thought, I promise. Then I'll try to take a question if they don't throw me off for being out of time. This widening gap between what users are asking for and what suppliers are delivering. And there's probably representatives of vendors in here in this room. We have put out this comprehensive report on what the opportunity is and what people need, what are all the trends in storage and data management in high performance storage across the landscape right now. So far, we have sold 0. This has been a phenomenal failure from a market research perspective. Not interested. A storage company that was a client of ours for more than 10 years dropped us this April and said, we don't need it. We just follow NVIDIA and go do what they're doing. You're telling me this isn't your market now, right? If you're serving the CoreWeaves and the Nebiuses or the Azures and the Googles, you don't need market research. It turns everyone else into fast followers. This is why I'm concerned, not just for, AI is coming from my business, I guess, not in the way you think, right? It's not that AI is writing this report. AI doesn't do this analysis, but it's taking the attention to a different part of the market. And I have to pivot as hard as anybody else. So the question to ask is, do you care about this market? And if so, are you going to go serve it? That is my presentation on 5 big questions for HPC and AI in 2025. Thank you very much. There's one behind you there.
He's ignoring me.
Yeah,
Okay,
you made the mistake of being behind him.
I know I'm insignificant. Thank you. Hi, that was really interesting. I was curious, what's the reasoning for the lower GPU or accelerator per server count for HPC versus AI? Is there like a reason for that?
Yeah, most HPC applications don't scale. Oh, so the question was, why would an HPC site use fewer GPUs than something that's pure AI? And the reason is that most HPC applications don't scale well on lots of GPUs, especially commercial licensed applications. And we described that thoroughly in a survey of the software ecosystem in 2023. It's the scalability of the software on GPUs.
Time for one more.
Bill Gervasi from Monolithic Power Systems, and I'm curious about the separation of edge inference at the edge versus data center. I mean, if I'm driving a car, I don't want to wait for it to dial into AOL before it decides that that's a deer in front of my car. How do you see that distinction between inference at the edge and data center centric?
Well, yeah, so the question was, what about why this segmentation of inference in the edge, and isn't it important? Of course it's important. You don't want the car to have trouble connecting to the internet before it hits the deer that it's about to hit. But what I mean is, from my analyst perspective, I'm looking at data center components, and I'm not counting cars as part of my market size. Certainly the companies that sell those services, whether it's Tesla or a cloud company, want to have that computing capability and inference out at the edge. But unless you're putting a data center in the car, I, as an analyst, am not going to go count it. There are some retail or finance areas where you're getting smaller data center components pushed out to the edge. And some of that has to do with things like federated learning, where you want the model to go out and visit and get influence. The influence updates the training. But again, from our perspective, we're going to count things that are clusters of servers and up. And if it's below that, it's just below our market methodology. And that doesn't mean it's not important. It's just not something we're counting.
All right. Thank you very much.
Thank you very much.
So we appreciate your awesome